Section 5.3, dividing decimals. So this is dividing decimals not by powers of 10. So we did dividing by powers of 10 in the last video, sort of snuck it on after we were talking about multiplying by powers of 10. So in general, dividing decimals, what's the strategy? What are we going to do? It's really going to be more long division with just a couple kind of small modifications. And the other thing that's sort of new is we'll get, we're kind of abandoning the long division where you would get a remainder. We're kind of throwing that out the window. And we will either just sort of keep going with the division until it ends with no remainder, or until we get what we call a repeating decimal, which is you get into some sort of a cycle where you're just getting the same kind of sequence over and over again, either one number, or you could get sort of a couple numbers in a row that are sort of repeating. In which case you could go forever. Obviously we don't want to do that, so we have a special notation to deal with that. Let's just maybe start with an example. Let's do 24.2 divided by 4. And so this is a decimal divided by a whole number. We'll do a little bit of a mixture of things. So first off, let's start with this. So having a decimal number and dividing it just by a whole number. So we're just going to set this up as long division. Oops. So set up as long division, and the decimal in the answer is above the decimal in your first number. So what this is going to look like, right? So this is 4 going into 24.2. So what I mean by the last thing that I just wrote, the decimal in your answer is above the decimal in your first number. I forget which of these is like the divisor and the dividend. I probably should have looked that up beforehand, but you know, the number under the division sign, right? What you're dividing into has the decimal. And so, you know, your answer, right, ends up just above here. And so what you're going to do is carry the decimal place here and just carry it directly up top. So in your answer, right, when you're sort of figuring out how many times does 4 go into this and that, all that stuff is going to carry just up top, and your decimal in the answer is going to be in that same position. Otherwise, we're just doing regular long division. So the decimal place carries up. 4 does not go into 2. 4 does go into 24 evenly 6 times. So that's 24, right? 6 and 4 is 24. 0. Carry it down. Don't, you know, as with a lot of these things, you kind of just ignore that the decimal place is happening while you're sort of going through the process. So this is not a 0.2 or something, right? That's not how we're thinking of it. As we go down in place value, everything is kind of maintaining its same thing. So this is just a 2. Now you say, well, 4 into 2, you know, how many times does that happen? And the answer is 0, right? 4 is not big enough. So this is where, you know, otherwise we would say, okay, so this is like remainder 2. That's not the situation now. So what's going to happen here, right, is if we get to this point where we kind of have leftover values, but we kind of have run out of digits, what we've said is with any of these decimals, you know, in theory, there are as many zeros as you want sort of after your last written value. So this is 24.2, but it's also 24.20 or 200 or 2000, right? And so on and so forth. So what we're going to do is just carry down that 0 as well. So this is really now 4, not going into 2, but 4 going into 20. Now, keep in mind, of course, we marked the 0 over the 2 as a placeholder, but now 4 going into 20 will go 5 times. So that's evenly. And so everything gets cleared out. So the answer here, right? So our solution is 6.05. So what we did is we just set up a long division. And essentially we just sort of kept going until we ended up going in, right, once we got through all the digits and also sort of finished with a whole value with no remainder. That's really our goal, is to sort of make that happen. So what makes this possible is that you have as many extra zeros as you want. So this is a type of problem and sort of a process where you can kind of just go and go and go, right? These values will sort of just continue as long as you need. Let's do 116.2. Let's divide it by 3. So again, whole number going into a decimal. 0.2, you know, we'll go out to 20 if we need to. I guess we'll just sort of see where we end up. And we'll just sort of start it, right? 3 does not go in to 1. Oh, I will mark, right, just directly up above. I kind of like doing this just right at the beginning. One key thing here is make sure you keep your work pretty organized, right? As I've said in other instances, and really always, it's good to be organized. But the place values here are super important, trying to make sure you're keeping everything lined up vertically as you go. So 3 does not go into 1, but it will go into 11. 3 times 3 would be 9. So we can subtract, right? That would be 2. Carry the 6 down. 3 into 26. 3 times 9 would be 27. Too big. So it must be 8. Would be 24. Okay. So 2. Now we sort of jump down into the decimal values, but that's okay. We've got the decimal here, right? As a sort of just carried up top. 3 into 22 would be 7, right? 3 times 7 is 21. So that's interesting. So now there's 1 left over. So what's going to happen, right? So now we've kind of run out of numbers, but of course we have as many as we want, sort of infinite zeros that we can kind of carry. So now 1, right, is not big enough. So now we'll call this 10. 3 into 10, that's going to go 3 times, right? Which is a 9. If I subtract, it's a 1. All right, so we got to go again. So we'll throw another 0 on here. Carry it down. So that's 10. 3 into 10. 3 again is 9. If I subtract, and now I'm left with a 1. And you're probably yelling at your screen already saying, wait, don't just keep going. This is just going to keep happening, right? So what's happening here? I ended up with sort of 1 left over. So I had a 0, which comes down, makes it a 10. You know, 3 is going to go in there 3 times, which is 9. If I subtract, I get 1 left over again. So then I write another 0, I carry it down, and then I go 3 times 3 is 9 again. You can start to see that I'm now kind of stuck in a loop, right? I mean, I could go zeros and zeros and zeros, and I could just keep carrying it down, and all that's going to keep happening is I'm just going to keep getting 3s and 3s and 3s just forever, right? So this is a little bit of a new experience for us. This is what we would call a repeating decimal. So this is 38.7, you know, 3333, you know, 3s as far as the eye can see, over the horizon, literally going forever. Now I don't want to spend the rest of my life just writing 3s on a piece of paper and doing long division. So there must be some sort of alternate way to write this. So this is a repeating decimal. And our notation, what you're going to do is write a bar over the repeating value. So what this becomes, right? So rather than 38.73333, you know, ... or something. I mean, you could kind of do that, but even that, you know, we don't really want that. What we want is 38.7, and then you do 3, and you just mark a bar only over the 3. So you just have to write the 3 once. You know, the idea is we're trying to be kind of efficient about this. So what we're saying is, okay, so I'm going to write, rather than write, you know, 3s through 3s, or you do a rounding thing, right? I mean, the idea when we're dividing here is we're trying to get, you know, as precise a number as we can. We're trying to write it as best we can. If you're going to use this to do a real life calculation, at some point you just have to figure out, well, how precise do I need to be? Do I need to carry this out, you know, 3, 4, 5 decimal places, whatever you need for that particular job. And then you can round it. But just to write it in a pure math class kind of way, what we're going to use is this bar notation. So 38.73 with the bar over it. So 3 repeating. And again, you don't need to write multiple 3s. You know, it starts here. So just figure out as soon as it starts, just write 1 bar. The 7 doesn't get the bar, right? Because the 7 is not part of the repetition. And that's what it's going to look like. This is, you know, one kind of downside if you're doing this calculator style or something, right? You throw this into a calculator, it's going to give you a rounded version, probably. Most just scientific calculators. They're not going to give you this sort of bar notation in the way that you would want. Let's do 1.45. Let's divide by 0.5. Let's do a decimal divided by another decimal. What's going to happen here? So in theory, this is like 0.5 going into 1.45. Now, the thing I don't want to do is have a decimal here on the outside, 0.5, right? My whole setup for long division is like, okay, how many 5s go into this? You know, am I supposed to say, well, how many 0.5s go into 1? The answer would be like 2, right? But I mean, that's so confusing. You know, how many 0.5, you know, if I go through this, how many 0.5s are going to go into 4? It's like 8. That stuff just seems off, right? That doesn't really seem like what we should be doing. And so the move here is shift the decimals in both numbers to the right enough that it's a whole number going into a decimal. So the move here, right, this would sort of be equivalent to, you know, rather than doing a 0.5 into a 1.45, the move is to sort of shift this and recreate it as, you know, 14.5 getting divided by a 5. If we kind of shift them both to the right by the same amount. So if I shift this kind of once over and this once over, I get 5 into 14.5. And that's perfectly legitimate. That works, right? It gives me something that I can understand a little better. 5 going into these numbers rather than a 0.5, which seemed confusing. My decimal just shifts up and everything is sort of back to being on track. 5 into 14 goes twice, is 10. This is 4. 5 comes down. 5 into 45 will go 9. And I'm good to go. So my answer here is 2.9. And that works great. That works perfect. Everything there is totally wonderful. So that shift sort of allows this all to happen. So if you're dividing by a decimal number, you want to do this shift in as many places as you can. We'll keep this going here. We'll do one more example in the next video that sort of is like this again.